Greetings, math students. This is MathCamp321, showing you a lesson on solving equations graphically by x-intercepts. The key concept in this lesson is that if you're given an equation in which one side equals the other, you can solve this equation graphically by moving all the things from the one side to the other and having the overall equation equal 0. So I say if y1 equals y2, and you rewrite this as y sub 1 minus y sub 2 equals 0, then the solutions to this equation will be the x-intercepts of the resulting graph. So looking at example 1, it says solve x squared equals x plus 6. So what I'm going to do is I'm going to take all the elements from the right and subtract them so that everything is on the left side, and that means we have 0 on the right side. So we're going to end up getting x squared minus x minus 6 equals 0. Now I'm going to turn the calculator on and I'm going to enter the left-hand side as y sub 1. So I'm going to go ahead and queue up the calculator, and I'm going to go to the y equals screen, and I'm going to type in x squared minus x minus 6. I'm going to start with a zoom 6, a standard viewing window. And you might remember from an earlier algebra class that this is going to be the graph of a parabola. And what I'm concerned about are the x-intercepts. This is where the graph crosses the x-axis. And there are two places where this happens. One of the x-intercepts appears negative and the other appears positive. And there's a way to do this on the calculator, so you don't have to just make a guess. You're going to press second, trace, and then you're going to press option 2, which is 0. A 0 is another word for a solution to the equation. So we're going to press option 2, and there's going to be 3 prompts. The prompts will be left bound, right bound, and guess. Left bound means move the cursor somewhere to the left of that 0. And right now the cursor is slightly to the left of that desired x-intercept. So I'm going to press enter. And you'll see a little triangular marker appears above that on the screen. The next prompt is right bound, so now move the cursor somewhere to the right of the x-intercept and press enter again. And you'll see another triangular marker appears, and what this is doing, it's telling the calculator where to look for that x-intercept. It's saying to the calculator that the x-intercept is somewhere in between these two markers. Now the third prompt is guess, and what I like to do is just move the cursor as close to the x-intercept as is possible, and then press enter one final time. And we're getting an answer of x equals negative 2. So that's going to be one of our solutions. And now I'm going to queue up the calculator again. And we're going to do the same exact process for the x-intercept that's on the right. Second, trace 0. Move the cursor just to the left. This time it happens to be a little bit below the x-intercept, so press enter. Now, right bound means go a little bit to the right. Press enter again. And now guess means put the blinking cursor right on top of where you think the x-intercept is and press enter a final time. And we get our second answer of x equals 3. So there are two answers here, x equals negative 2 and x equals 3. Now it's possible that you could have walked up to this equation and known how to do it by hand, and that's fine. So this would have been a nice way to check. Or let's say you just had no idea how to do it at all. Maybe you could have done it this way. So looking at example 2, it says solve x cubed minus 2x squared equals negative 1. Now this is a cubic equation. It's a little bit more complicated, but with the tools that I've just given you, you'll be able to do it. So let's take the element negative 1 from the right side and move it to the left side, making it say x cubed minus 2x squared plus 1 equals 0. And we're going to call all the elements on the left-hand side y sub 1. And now I'll queue up the calculator. I'm going to go to the y equals screen. I'll clear out example 1, and I'll enter example 2, which will be x cubed. There's two ways to get cubed. You could use the little caret here, followed by a 3, or the math menu, option 3 is cubed. X cubed minus 2x squared plus 1. And I just happen to know that when you graph a cubic, you end up getting this wiggly looking shape. Sometimes the wiggle is really gradual, but other times it's more severe. Let's see what happens in this graph by pressing zoom 6. Okay, so there's our wiggle. Now I'm focusing in on the x-intercepts, and it's kind of hard to tell because it's small. So I'm going to use zoom box, which allows me to create a new window on this new box that I create here. So I'm going to do zoom box, which is option 1. I'm going to move the cursor forming a rectangle, and then I'm going to press enter at the corners of that rectangle. So I've just pressed entered, and I'm going to drag down and then drag over. And I think this rectangle right here is going to capture the x-intercepts that appear kind of small right now. So I'm going to press enter, and that rectangle will become the new window. So there's 1, there's 2, and there's 3, and they're pretty clear. So I'm looking for 3 x-intercepts. Let's go from left to right. Second, trace 0. Move the cursor all the way to the left. It says left bound. Now means just go a little bit more to the left than the actual x-intercept. Now go a little bit to the right where it says right bound. And then guess means go on top of that. And then press enter a final time. You know you're done when it says 0. If it doesn't say 0, you haven't pressed enter enough times. So in my class, we round to the nearest hundredth. So I'm going to say negative 0.62. Okay, let's call the calculator up and move it over a little bit. And now I'll find the x-intercept in the middle. Second, trace 0. Left bound means go somewhere to the left, which I am. Right bound means go somewhere to the right, which I am. And guess means go on top of it, which I am. It says 0, and the second x-intercept from left to right is x equals 1. Okay, and the third and final x-intercept from left to right, second, trace 0. Left bound means go somewhere to the left. Right bound means go somewhere to the right. Enter means, guess. Guess means go somewhere on top of the x-intercept, and press enter one final time until you see the word 0. And our third x-intercept is at 1.62. So that was example 2. Example 3 has us solving the absolute value of x squared plus x minus 1 equals the square root of x squared minus 1. I used this example in a prior video. So this is not something that I know how to solve by hand, so I'm going to be forced to use some sort of technology. So I'm going to use the graphic calculator, and I'm going to do this by x-intercepts. I'm going to take all the elements from the right, and I'm going to subtract them and move them to the left. And it's worth noting that students usually ask at this time, if you wanted to, could you take the elements from the left and move them to the right? And the answer is absolutely. You can do that. The graph is going to be upside down from what it would have been had you done it the original way, but the x-intercepts will be the same. So maybe for fun, let's do that right now. Why don't we move everything to the right just to be different about it? So I'm going to say 0 equals the square root of x squared minus 1 minus the absolute value of x squared plus x minus 1. Okay, this big expression on the right now is going to be my y sub 1. So I'm going to queue up the calculator, go to the y equals screen, clear out my existing entry, and then enter this monstrosity. Second, x squared, which is your radical, x squared minus 1. Come out of the radical, minus, absolute value is math, scroll over 1 to the right where it says num, and then absolute value. And you'll see in my calculator with my particular version of the operating system, you see the absolute value bars. So I'm going to type in x squared plus x minus 1. So I've got that entered in. And I'm going to press zoom 6, and we'll see if that's a suitable window for me to clearly see the x-intercepts. Now it looks like from this vantage point there are 2 x-intercepts. There's a little region right in the middle where there's nothing happening at all. I think I'm going to do a zoom box, zoom option 1, and usually that starts me off at the origin, and I'm going to move a box. I just want to capture these 2 a little bit better. Go a little bit lower here. Press enter to start the box, and then just drag like it's a very, very fun video game. Capture the x-intercepts. So this rectangle is going to be my new window when I press enter one final time. Here we go. Okay, so it looks like there are two x-intercepts. We'll find the first one from left to right. Second, trace 0. And right now we can't even see the cursor because there's that little region in the middle where there's nothing happening. But there it is. If we keep trying, it does show up. We're moving now to the left. Press enter. Right bound means move to the right. Press enter. And then guess means put the cursor as close to the x-intercept as you can. And we see the word 0, which means we're done, and we're rounding to the nearest hundredth. So it's negative 2.33. And let's find that final x-intercept and then we'll be done. Second, trace 0. Let's move to the left. Let's move to the right. And let's put the cursor right on top of the x-intercept where it says guess. And our final answer is negative 1.23.